Hello there, my name is Gary Sims from Android Authority. Now, if you hang around with nerds, with technical people long enough, maybe they'll use vocabulary that you're not familiar with. They might use words like machine code or assembly language. And when they use it, you kind of just smile sweetly and let the conversation carry on because you don't really know what they're talking about. Well, today I want to explain to you what is machine code and what is assembly language. Now, we're all used to running multiple programs on our mobile devices, whether they're laptops, tablets or smartphones. We run a program, we start it up, we use it, we close it, we start another one. Whether it's a word processing suite, an email client, a game, a graphics program, we're very used to going into a program, exiting it and then going into another one. But it wasn't always like that. At the beginning of the history of computing, the initial computers were hardwired. They could only perform one task. The circuit that was built into them, that was the task that they performed. Of course, it became obvious very quickly that we need a universal computer, one that can perform any task that it's programmed to do. Now, there are two key characters in the history of the development of the stored program. One is Alan Turing and the other is John von Neumann. Now, Alan Turing is famous for breaking the Enigma code during the Second World War, but he also did a lot of other things related to computer science. In particular, he came up with the idea of a thing called the Turing machine. Now, he proved with the Turing machine you could execute any computable algorithm. I won't bore you with the details of how he talked about it, but basically he had the idea of some symbols that could be read and other symbols could be written to a tape, because that was the technology of the time. Now, this idea was picked up and taken further by John von Neumann. Now, von Neumann proposed the idea of a CPU, a central processing unit, with some memory, random access memory, and that the CPU executed instructions and then could alter the random access memory. In fact, the majority of computers that we use today use what we call the von Neumann architecture. So what does all this have to do with machine code and assembly language? Well, machine code is the name given for those instructions that are executed by the central processing unit. They are in fact just numbers. They're a long number that tells the computer to do something. For example, under the ARM architecture, the number 288 means move 1 into register 0. Now, a CPU has registers. They're kind of little pots, little holes that you can put data in, and you can do something with them quickly and then maybe put something else in it. They're very temporary. The ARM64 chips, for example, only have 64 registers, so they can't replace main memory. They're not talking about gigabytes here, you're just talking about a few places to store temporary data. And they're great when you want to perform, maybe do something with a string, you can do things in little registers. Now, each of these numbers, 288, move 1 into register 0, each of these numbers means something different. Now, of course, if you imagine writing that by hand, trying to remember what 288 is, what does 329 do, what does 54 do, all these different numbers would be almost impossible. So in fact, there's another thing which is a slightly higher level, more human-friendly version of machine code called assembly language. And rather than just talking with raw numbers, there's some opcodes, some short codes that say, I want to move something into a register. Now here's an example. And as you can see, that tells us that we want to move 1 into register 0. Now, assembly language, when you start writing it, it's in a text file. It has to be converted into the machine code by a thing called an assembler. So an assembler takes this very low level code and turns it into machine code, which the CPU knows how to execute. So here's another snippet of assembly language, so you can kind of get an idea of what it looks like. Now, what this one does is it takes the number 15 and puts it into register 3 and then stores it somewhere on the stack. Now, I'm not going to get into stack now, but basically it's a part of memory, and it says here that this number is stored 8 bytes down the stack. It then takes the number 25 and sticks it into R3 and then says, let's store that at the 12th position on the stack. And then finally, it adds those two numbers together and stores the result again in R3. Now, in a higher level language like C or Java, you would probably do this in just 3 lines. I is equal to 15, J is equal to 25, I is equal to I plus J. So as you can see, using a higher level language is easier, just 3 lines of code rather than 8. Now imagine if you had to write a game like Clash Royale or Riptide GP using just assembly language. Now, it would be possible, and in fact, in the days of the home micro revolution, the BBC Micro, the ZX Spectrum, the Commodore 64, that's what game programmers did. They wrote it all in assembly language, quite an amazing feat if you think about it. But today we would use a compiler. Now a compiler takes a high-level language like C and converts it directly into the machine code. So the C compiler looks at what you want to do. I want to set this variable, I want to add these two numbers, and it works out what it needs to do in the assembly language and then in the machine code to actually get that to happen. Now there are other programming languages. In Java, for example, which is the main programming language for Android apps, what actually happens is you use a compiler that converts the Java code into Java bytecode, a kind of like a type of machine code, but it's for a virtual machine, not for a real physical processor, but for a virtual one that exists on the Android phone. And then it runs through a thing called a virtual machine, which interprets those byte codes, those machine instructions, and turns them into real instructions for the ARM processor, or for an Intel processor, or for a MIPS processor. And the idea, of course, is that therefore you can write apps and you can actually have them on any architecture that you want, because it's the virtual machine that's running them, and then there's just one little step you have to write when you implement Android to make it work on that particular processor. Of course, at the moment, the ARM processor is the most dominant one. So you've got a compiler that converts it into bytecode and a virtual machine that runs it on the Android phone. Now, if you want real high performance, then you really should be writing your game, let's say, or your mathematical modeling program or whatever it is you want to do in C or even in assembler language. Now that's possible. There's a thing called the Native Development Kit, the NDK, which you can get from Google, which allows you to write C and assembly language directly on your Android phone, and that bypasses the Java virtual machine and uses compilers and assemblers to create that code. But let me warn you, nerds only need apply. So let's do a quick sum up here so that you can really get the essence of what's going on here. Old days, computers fixed, couldn't do multiple tasks, weren't universal, go do one thing. He invented the idea, Turing and von Neumann invented the idea of universal computers that could have memory and a CPU, and they could execute instructions, and those instructions are called machine code. For us humans to create that machine code, there's a slightly higher level readable form called assembly language, which converts directly into machine code. And then above that, you get languages like C and Java and other languages that exist that can compile to machine code to run on a processor. I hope you got all that. Well, my name is Gary Sims from Android Authority, and I hope you enjoyed this video. If you did, please do give it a thumbs up. Also, please use the comments below to tell me whether you've written any machine code. Have you written any assembly language? Do you like writing in high-level languages? Do tell us about your experiences with these low-level things on your Android phone. Also, don't forget to subscribe to Android Authority's YouTube channel. You can follow me on Twitter, and if you use this link here, you can find me on the Android Authority forums. There's a place on the forums where you can ask me any question. Ask me about machine code, ask me about assembler, and if I can help you, I'll get back to you. And also, don't forget to stay tuned to AndroidAuthority.com, because we are your source for all things Android.